Alright, find the equation of a line in point slope form that is perpendicular bisector. So I need the midpoint. So the midpoint would be averaging those two guys, add them together, divide by 2. That's how I got the 1. Add those together, and I get negative 3 divided by 2 is negative 3 over 2. So that's part of what I need. I also need to have the slope so that I can find the opposite reciprocal. That's what perpendicular means. So the slopes will be the opposite and the reciprocal. So I found my slope, and that's the slope between these two guys. But the perpendicular slope would be flipping that over and making it the opposite. Got it? And then I just plug it in. There's my slope. There's the point I'm using. And I just distributed, subtracted 3/2 over, and that's how I got my answer. So I just take that point right there. And then I go, oh, I'm going to multiply it by negative 3. So there's my negative 3. Multiply by negative 3, that gets me down here. Then it said, move it forward to the left and up 1. There's my dot. I just did that for each one of the points. So this one over here, so that's that guy. Multiply it by negative 3, so I'm sitting at negative 1 times negative 3, way up there. Move it back 4 and up 1. I just keep plotting all those. This is the correct graph. This is my original copy that had an error in it, so I fixed it. Your test didn't look like that. So if I take a point from here to here was 2, so from the top to the bottom, 1, 2, 3, 4, 5, 6. So for that distance to increase to 6, it would be times 3. And then this point was at 4, and now it's over here at 5, so it's moved over to the right one. And then I just grab a point and start figuring out where it should be. So if I grab this point right here, that one right there, here he is. So I multiply them by 3, and I get 2 times 3 is 6. 1, 2, 3, 4, there's 6. And then move them over 1, and then how far do I have to go down to get it to match here? 1, 2, 3, 4, 5, 6, 7, boom. $16, I'm going to change it to a base 2, so 2 to the 4th. So that would be 2 to the 4x. And then the cubed root means you're dividing by 3, so that's 4x to the 3rd. That one's just 2 squared. Negative 3. And 2 distribute. Multiplied by 3. Many mistakes on multiplying the street. A lot of people forgot it to multiply it here or here. That's where your common mistake was. Then you just solve it. This is my original copy. I changed a few things. So this was the 44 and that was the A. I wanted you to have to solve it a little different. Sine, opposite over hypotenuse. Tangent, opposite over adjacent. And the cosine is adjacent over hypotenuse. Law of cosines. So I found this angle first. So I used that side. Squared equals these two sides squared minus 2 times those two sides and the cosine of that angle. Solve it down, subtract that guy over, divide by this guy, and then do the inverse cosine. There you go. There's your angle. Then I use the law of sines. So sine of this angle over its opposite side is equal to sine of the angle over its opposite side. And that's how I ended up with 60 degrees. And then I just use 180 minus those two guys to get here. And you could use any angle. I chose this angle and these two sides. And there you go. Don't forget it needs to be sine, not cosine, if you did that. Five pi over 3 all the way around here, because that would be 6 pi over 3. So you go back 1, This sine is the y value. So that's square root of 3 over 2, since I know that reference angle is 60. And it's negative because it's going down. I like it when it's divided by 4 because then I know it's 45, 45, 90 triangle, and that would be a 45-degree angle. 4 pi over 4, coming back 1, 45-degree angle. This is square root of 2 over 2, but it's negative since it's going negative direction. Cosine of pi, right here. Look at the coordinates. Negative 1, 0. And cosine is the x-coordinate. Domain restriction. So I have to start at pi over 2, and it can go all the way to 2 pi. And I know that cosine is positive, so it can only be here or here, but we eliminated that quadrant. So I know that's a 45-degree angle. 8 pi over 4, so this would be 7 pi over 4. From pi to 2 pi, pi to 2 pi, that's the domain I can use. I cannot use this part. Sine is negative 1. That is the y value of negative 1, so that's 3 pi over 2. Pi over 2 all the way to 3 pi over 2. And then sine has got to be negative, so it's only down here and here, but we cross that part out. So it's just over here, so 7 pi over 6. Since I know that reference angle is 30, is always across from the half. Last problem. I just plotted the points. You can just, I know that this graph is shifted over 5 and up 6, so I went over 5. 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 6, put a dot, and I know it looks like a V, and I stopped where x is greater than 3, slope and y-intercept. Did that, stop, open circle because of it's not equal to it. Then I had to move it over 4, so I took this point, moved it over 1, 2, 3, 4, and then down 6. 1, 2, 3, 4, 5, 6. And then I just moved all the points that way. Substitute that part in for the x, and then just subtract 6 at the end. So when I plug this x minus 4 in here for the x, that's x minus 9. That's how that got there. 6 minus 6 is gone. And same thing for the top. And this spot moved from 3 all the way over to 7. So that's why its x is less than 7.